Satellite images in Google Maps as well as in Google Earth are presented as so-called natural colors. And this is actually the limitations for these images and for these online tools. Why we believe it is a limitation? Because valuable part of information is lost while presenting these images in natural colors. On one hand, it should look like natural and like you would see it with your own eyes, flying on the plane or spaceship. But actually, the modern satellites could see more than you could see with your eyes. This is just an example. For example, this the satellite images for Untitled Mountains in the northeastern United States. And actually, you could see that all forested area, it is just more or less the same colors, like gray and green, and you do not see much details. Of course, if you will zoom in some big cities and populated areas, you will see some colors, different colors of cars, of buildings, and so on. But for monitoring of nature, for studying natural objects, it is not really very useful. Although forests, for example, will look more or less the same. There are some other online tools, online maps, which could help you to go around these limitations, and just to show you what else modern satellites could reveal with satellite images. This is a portal of laboratory of the University of Maryland. There's a big international team working at that university, and this is one of their famous product, the portal called Global Forest Change, and actually it indicates the results of monitoring of global changes in the forest cover, monitoring satellite images. But we will, I think I would recommend you to study this portal by yourself, spend time on this. This is pretty interesting. You could see these data products about tree cover and changes in the tree cover, but we will just switch off the data products for a while. And actually in the background, we see the same Google Maps as we see in the Google Maps portal, and the same set of satellites as you could see in Google Maps and by default in Google Earth too. I would just recommend you to switch off labels, and you will see that regular Google Maps images. But there is also other satellite images available here, so-called background images. And if you will look at the list of possible options, you will find the images available for the year 2000, pretty old one, and 2001. And they are so-called, you could see the word bands, the combination of spectral bands. What does it mean? I will now explain. These images are taken from the Landsat satellite series. This is already a pretty long-living series of American satellites who are right now, if I'm not mistaken, 3 of them are operating in the orbit and shooting our Earth from our planet from space. And actually, the products of this University of Maryland Global Land Analysis and Discovery Lab, all the products are based on the images from these Landsat satellites. And you could just let you use this file freely for combination, and you will see our world in a totally different colors somehow. what we could see in Google Maps are called nature colors. And what we see here is, of course, this is not the native colors of our planet, but this is so-called false colors. So we just presented some of an invisible light, infrared, first of all. We presented visualized here as visible light. So I will just skip this example. This is just how I have done it. Step by step. And actually the background imagery here is not the one moment shot, just a composition of many images from one side, 7, 8, and recently 9. And they are combined together as a cloud-free images for vegetation period. And you could just take a look at the same area of Adirondack Mountains, as we have seen. I do recommend you to switch off labels. And let us compare what you will see with background imagery in full screen mode, if you wish. So you could compare here the image in natural colors, and here is the image in false colors. You could, for example, see much more grades and much more shades of colors in the vegetation, and you could separate different types of forests from each other. And actually, if you will just, with Adirondack Mountains, it is just a tiny examples. I have collected a number of screenshots from that system, so you could just show you how much of new information you could get using these so-called false colors. For example, here, this is the fragment of Mekong River Delta in Vietnam, Southeast Asia. In Google Images in natural colors, you will see virtually all of this area just in these shades of gray and green, basically. And if you will employ these invisible infrared channels, visualize them, you will see, of course, a very big difference between rice fields, other type of fields, and other types of vegetation. All this dark blue is actually the rice fields, covered with water, irrigated. They are all irrigated and require a lot of water for growing rice in the Southeast Asia. And you could see the water area here in this satellite image. Just compare that and that. And all the dry croplands, dry fields, you could see, for example, the central part of the image, in the upper part, you could see other types of crops, maybe other species of rice, but most probably it's a wheat or something else. In the very center, there is also a fragment of natural vegetation, of bushes and trees, and some wetlands, some grasslands. I believe it is a nature reserve. This is why it is preserved here in that somehow polygonal shape. And in the lower left corner, you probably could see some plantations, something like tea plantations and other type of not really crops, but not 1 year crops at least, but the long-term growing trees, maybe fruits, maybe tea plantations or something else. Just another example, this is a Gummy River in West Africa, and you could see a lot of forest area. This looks also all the same, all of some shades of green. But also, if you will take a look with using this Global Forest Change portal, you will see the huge difference between these mangroves, like bright green here along the river, and dry deciduous tropical forests, which are brown here and brown green. And this difference is now very clear. Here you see virtually no difference. And here you could see this difference very, very clearly. Another example from British Columbia, from Canada, just you could see fresh clear cuts. You could separate them from forest, all these polygons of irregular shape. You could see even with Google images, but all the forest around looks more or less like the same. And only with another combination of spectral bands with infrared light, you could distinguish, at least you could separate secondary deciduous forest and light green, and native coniferous forest and in dark green. And you could, it is quite evident that particularly with coniferous forest are being logged primarily. And also you could see that clear-cut plots were also different in color. The pink and magenta color are just fresh clear-cuts. There is still no regrowth, no vegetation. And in the old clear-cuts, you could see the forest slowly coming back, regrowing. But this is a different kind of forest to become again with very dark green coniferous, native coniferous forest. It will require decades and decades, and probably hundreds of years even. So how actually could we make the invisible infrared light visible? So the modern satellites could detect this invisible infrared light with their sensors and record separately, for example, visible red light, the so-called near-infrared light. It means the infrared light close to visible, and shortwave. Different kind of infrared lights could be recorded separately. And of course, you could somehow visualize the results of this measurement as a shades of gray. The more intensive would be the infrared light, the brighter or darker it will be in the image. But of course, you could not only show this infrared light as a shades of gray, but you also could show them as a shades of blue, green, and red. And this is a way to visualize it. Just imagine that we could take 2 or 3 different kinds of infrared lights and color one of them in shades of red, another in shades of green, and another in shades of blue. Or actually, in this particular case, we could color them visible red lights in the shades of blue. And you know that the image in your screen, in your computer, is somehow synthesized of these 3 basic colors, red, green, and blue, this so-called RGB synthesis, which is used virtually in all modern computers. And just combining all these 3 colors together, we will have this RGB color composite. Mixing these 3 colors, you will visualize the invisible light. The invisible infrared light will be visualized in that combined image, just shades of red or green or all together, and you will see this unusual colors picture, which is called the composite image or multispectral image. Basically, this RGB image produced this way, it looks unusual, as you have already notified. And those colors are called false colors because this is not what you see with your eyes, but you somehow presented with the colors you could see, you presented the colors, the light which you cannot see, but the satellites could detect them. And you put these false colors, and sometimes they could reveal much more information, particularly about vegetation and about humidity. Just let us just go through and take a look. This is the city of Manaus, the capital of Brazil's state of Amazonas. strictly speaking in Spanish. And it is presented in a false color in the synthesis of spectral bands number 4, 5, and 6 by Landsat 8 and 9. It doesn't matter, just 2 of them are not visible with human eyes, but could be detected with a sensor of Landsat 8 and Landsat 9 satellites. So what do all these colors means, which you see? You see that a big part of images is still green. And in that synthesis, the green is still different kind of vegetations. But you see with various shades of green, you will see different vegetation types. For example, this bright or darker green, it's an intertropical rainforest, where it looks like that kind of green. And croplands and some secondary forest you could usually see as a lighter green, or sometimes see even as green and yellow combination, a mixture of green, yellow, green spots. And this is all this somehow logged forest or regrown after logging, or some artificially planted trees, or some croplands you could see in that light green colors. And this magenta, you could see the city of Manaus is mainly in these pink and magenta shades, pink and magenta colors. And this is actually the color for artificial surfaces, like stones. In nature, it could be some open sand, open rocks, and so on. But particularly here, it is the human-made materials, all these paved roads and buildings, they will look like that. But also you could see the water in that image, and you could even see 2 different kinds of waters. In this particular area, this is exactly the location where the river of Rio Negro meets the river of Amazon. And you could see that the color, that the waters of these 2 rivers have different colors. This Rio Negro, it has a water which looks actually black in that image, not necessarily black in the reality, but this is basically clean water. And this is why it looks black. And the river of Amazon, it contains a lot of some small particles. It is turbid water. This a lot of very, very small particles of sand, of minerals, and maybe also some plankton, algae, for example, and so on. And it looks very different. It reflects the light differently. You could see it in blue. So looking at these false colors images, you should be able to interpret what actually do you see. Just let me show you a few more examples. This is a croplands also in Brazil, in Brazilian state of Mato Grosso, and it is also in false colors. So you could see many particular croplands. You could see that all of them are of different colors, and actually the fields with growing crops, they are also green, but it is much, much lighter green rather than a green for forest, for tree vegetation. You could see, like, I would say yellow-green or light green or bright green colors or shades of green. And this in that synthesis of the synthesis of the spectral channels, you will see it as this kind of color. And the fields which have already have been harvested or just plowed for next crop, for growing next time. And actually in this particular area, you could harvest crops 2-3 times a year in Brazil. Where looks with pink and magenta shades. And this is also a signal from bare ground. It looks a little bit similar to artificial surfaces in the built-up area in Manaus we have seen in the previous image. And we also here you could see some remnants of a forest with the dark green stripes along the waterways, along the rivers or small creeks. This is where the forest survived. And you could see they look really differently from the croplands around. Another example with forests. This is a tropical forest of Madagascar. And you could see two different types of forests here. On the right side, in the east, you could see this humid tropical forest, similar to Amazon forest, but in the mountains, mountain type of forest. And in the left, the western part of the image, you could see this brown forest, where dry. This is also tropical forest, but where dry tropical forest, and where deciduous. So in the dry season, they could drop some of the leaves, and they have that kind of red and brown colors across the dry season. And also you could see here is the humid forest, and this is a dry, so-called spiny forest. And also you could see some pink areas. It is just treeless, probably clear it from forest for some agricultural purposes, so probably all of these spots are human-made. Yet another examples. Again, this is a logging in the Boreal Forest in Oregon, far north, in the United States, also in false color, the same synthesis. And here you could also see very clearly the difference between primary coniferous forests, the secondary deciduous forest after logging, and also you could see fresh clear cuts of this pink color, just freshly made, and still having no vegetation on them. Also, this is just an example of various alpine vegetation in the Caucasus Mountains in southern Russia. You could see all types of vegetations in the mountains closer to the summits, to the top of the summits. You could see also some snow and ice at the highest locations, at the highest elevations. And going down, you will see bare rocks and some very sparse vegetation called mountain tundra. And there's even not grasses, but something much, much smaller, like lichens and mosses, and only some grasses. And then downslopes, you will have also pretty large areas of alpine grasslands, so-called alpine meadows, which are suitable for grazing and widely used also worldwide. And in the values, you could also see some various types of forest, including both deciduous and coniferous forest. And so you could see all types of vegetations in a very, all types of, I would say, land cover. It is hard to call snow and ice a vegetation. So you could see all this type of land covers in a pretty limited area. And a few more unusual examples. For example, this is a huge wetland area in the central Siberia, Vasugan wetlands, also in the false colors, and you could see just different types of wetlands. There's virtually no forest here, no real forest at least. But you could see here a different type of bogs and swamps. In this gray, I would say green color, light green color, you could see this oligotrophic bogs, mainly with sphagnum mosses. This is a very pretty common ecosystem in the north. In the humid and wet conditions. And actually it is an open landscape. If you have never been there, it is hard to imagine, but it is a very specific landscape, a huge open area, which is a very swampy and very wet, and it is even very difficult to move over it. But there is even more wet area, this more eutrophic and mesotrophic box with some different type of vegetation, also very wet, but looks really differently here. And also in more dry positions, there is some trees, mainly probably in this particular case, were small pines, dwarf pines, suppressed Scotch pines. And this is practically like a very, very wet forest, like a forested swamp. Just some more pictures I collected for you for this presentation from this Global Forest Change website, just to show the diversity of our worlds in that false colors. For example, these are irrigated croplands in central United States and close to Colorado-Nebraska state's boundary, and you could see the circles. It's just because the irrigation is shaped in that way. This fields is like circle, not the rectangle. That's another kind of croplands. Here you could see also this wet rice fields in Bangladesh on the right side, and more dry, also mainly croplands and some populated areas on the left side. Just pay attention to the scale bar in the lower right corner. So you could see it is a pretty large area. But you could see the still much details and different types of vegetation here. Just very, very different landscape. Dry grasslands, actually dry steppes in Mongolia. This is totally treeless landscape, and only around the waterways you could see some more healthy and some more developed vegetation, and the other areas is covered with grasses. But in the midsummer, the grasses are so dry that you virtually see no green color here. You see all these dry grasses, they look like these reddish shades. And this is not exactly the bare ground, but this is the reflection from very dry vegetation. Also, you could see some dry shallow lakes, which looks blue, not mainly because there is turbid water in them, but just because they could be very shallow. You could see the bottom of these lakes. Probably they are salt lakes. Just another extreme dry location with the sands in the Taklamakan Desert in China. They are just a pink color. It is just sand dunes, bare sand, and only along the river. By the way, it is probably a temporary waterways, not permanent rivers. And you could see some irrigated croplands, and this is the only place in the desert for people to live. And this is another desert. There is no place to live here at all. This is just a sand dunes. This Namib Desert in southwestern Africa, and this is one of the probably the driest places in the whole world. There's virtually no rain at all the whole year, and it is extremely difficult for plants and animals to survive there. Only some of them could survive. Just virtually bare sand. A few mountains landscape. This is the Appalachian Mountains in the eastern United States. So you could see some mainly forest area and also some small croplands in the valleys. But they are mainly deciduous forests here. That's another type of mountains, Zagros Mountains in Iran, and this is extremely dry area. You could see the vegetation is here very poor, only in some slopes, which could somehow accept some precipitation. You see some very dry shrubs vegetation, and in many cases it is just a bare soil as well. It looks like a desert, it is a up way in the mountains. Just very nice picture of the Mississippi Delta, the place where the Mississippi River comes to the ocean, and the sediments of which come this river, they are being deposited here, close around the river mouth, and creating a number of these small islands, looking and also making a river makes branches through these islands. You could see also different shades of water. So some turbid water coming with rivers that has this brighter blue colors. Just another type of a river mouth. This is a mangroves in Sundarban, but also you could see many river branches. This is also a kind of a river delta, but it is covered with that kind of tropical vegetations. Just I would say the mangroves are a forest growing virtually over salted water. A specific type of forest, like a swamp. Usually you have water under these mangrove trees. And that's another type of a river delta in the very far north. It's a river Lena Delta coming to the Arctic Ocean in the northeastern Siberia. And here, this is a tundra vegetation, also treeless landscape, but you also could see many river branches, many islands, and many small lakes in tundra condition. Although in tundra, there is not actually a lot of precipitation over the year, but it is pretty cold there, and water does not evaporate much, and so the tundras are usually over humid in over humid conditions. Just a couple of other examples of tundra. That's the tundra in Taimyr Peninsula in northern Siberia. Also, you could see many small lakes and virtually lack of any tree vegetation. But there's many small bushes and grasses and other small plants surviving in that hot northern conditions. That's finally the Canadian so-called low Arctic tundra. Also on the coast of the Arctic Ocean, and also you could see many small lakes, and you could see this kind of reddish colors and brown and reddish colors. This is an effect created by sparse vegetation. So the signal from bare ground rocks is mixed with the signal from some sparse tundra vegetation, and you could see, as also in wetlands, as you have seen, you could see this wide variety of strange colors, and you could separate different type of vegetation based on these colors. You could reddish and brown and pink, and many shallow waters here. And finally, a few volcanoes. For example, this is St. Helena volcano in northwestern United States. You could see this summit of volcanoes with some snow around, but also you could see the crater, the tracks of magma coming from volcano, and around the crater you also see these bare rocks. They are even not magenta, but even blue. This is not a water, but just mainly bare rocks. So you could see them, no vegetation at all. All vegetation could come even lower, and down slopes you could see also some different kind of forests and lakes. Just another example, the group of volcanoes in Kamchatka Peninsula in the Russian Far East. You also could see snow on the tops, and you could see these tracks of magma just erupted. And you see that along this ways, there's still no vegetation. Vegetation could come only later, some decades or sometimes hundreds of years after eruption could be restored. And that's another very famous volcano, Mauna Loa in Hawaii Island. And you could see also a huge area where vegetation is destroyed by previous eruptions. And it is very difficult to restore it here. And you could see these tracks of erupted materials of magma, and the vegetation is totally destroyed along these tracks. And you could see these barren rocks colors here, and only see vegetation down there, more from the crater and on this ways of magma. Thank you. That's the end of the short excursion.